My name is Professor Virendra and I'm from RIT Engineering College, and today we are basically going to learn about Maxwell's smooth current method. Now before we go for Maxwell's smooth current method, the first thing what we have to know is what is basically KVL, because KVL is a part of Maxwell's smooth current method. Now KVL is Kirchhoff's voltage law. KVL states that the number of voltages is equal to the number of voltage drops in that particular loop. So if I'm using KVL here for this particular loop, I can derive it as V1 is my voltage source, R1 is the resistor in this loop, R2 is the resistor in this loop. So we have a voltage drop across R1 and we have a voltage drop across R2. So VR1 is the voltage drop across R1 and VR2 is the voltage drop across R2. So using KVL, which states that number of voltages or number of voltage sources is equal to the number of voltage drops. So I take the voltage sources on one side, V1. Since we have only one voltage source, it will be equal to the drops in R1 and R2. So we have the voltage drop in R1 represented as VR1, and we have the voltage drop in VR2 represented as VR. So this is our equation. So basically this is known as Kirchhoff's voltage law, which states that the number of voltage sources is equal to the number of voltage drops. Now we are using the same logic in Maxwell's loop current method. Now this is only one loop. This is only one loop. But in real life situations we will have more than one loop. So we'll have 2 loops, we'll have 3 loops, 4 loops, and so on. So in order for us to find out the currents in all these loops and the voltage and the current ratings in all these loops, we have to use this method. So first thing in Maxwell's loop current method, for this problem, we have totally 3 loops, loop 1, loop 2 and loop 3. So we will underline these loops. So I highlighted this as loop 1. As we see here, there is a loop formation. Same way, there is a loop formation here. So this is taken as loop 1. I can take this as loop 2. And I can take this as loop 3. So totally I have 3 loops. So this is my loop 3. My loop 1. And my loop 2. So I have loop 1, loop 2 and loop 3. Now using the same logic what we have discussed here, I am going to find out my voltage sources and my voltage drops in this particular loop. So I will find out for loop 1 first. Then I am going to find out for loop again and then loop 3. Now before we start Maxwell's loop current method, the most important criteria is basically mark your polarities of your voltage sources. So this is positive, negative, positive, negative, negative, positive. Okay. Now there is a current flowing in this loop in the same way how current flows in this loop. But our direction of current is very well known because this is positive and this is negative. So current flows from positive to negative. Electron flow is from negative to positive, but current flow is always reverse of that of the electron flow. So current flows from positive to negative. So obviously my direction is going to be in a clockwise way. So we have a clockwise direction for I. This is known because there is only one voltage source which is positive and negative. But we cannot apply the same logic here V1 which has positive and negative, wherein the current from here is flowing clockwise, and the other voltage source V2, if you see, the current flows in anti-clockwise. So we are not sure whether the direction will be clockwise or anti-clockwise. So initially at start we have to assume this direction. So we'll assume a particular direction. So I'm saying let all the currents, this is I1 representing loop 1, this is I2 representing loop 2, and this is I3 representing loop 3. So at start I assume all the directions of the current. So I'm assuming them in clockwise direction. So I am assuming all the currents in clockwise direction. So this is the first assumption that has to be done. So before we start Maxwell's loop current method, assume all the current directions, draw the loops, label them loop 1, loop 2 and loop 3. Now coming back, applying KVL in loop 1. How we apply KVL here? So we apply KVL in this loop. So when we apply KVL, in loop 1. So in our loop 1, what we have? We have V1, we have V2. Always remember, start with all the voltage sources and then start with all the voltage drops. So how many voltage sources we have? We have V1 and we have V2. V1 is how many volts? 20. V2 is how many volts? 5 volts. Now, what direction of current we have assumed? A clockwise direction. We have assumed a clockwise direction. V1 is positive and here it is negative. So current flows from positive to negative. So my V1 direction is flowing how? In clockwise. Positive to negative. So it is following the same direction of this I1. I1 is also flowing clockwise. Even V1 is also flowing clockwise. So V1 will be a positive voltage. So if V1 is a positive voltage, we have V1 here. Then what about V2? V2 is flowing in anti-clockwise. Why? Positive to negative. See the direction of my finger. From positive to negative. So this is anti-clockwise, which is opposite to that of I1. So if it is not in the direction similar to I1, then it will be in negative. So negative V2, which is equals to voltage drop across this 5 ohms resistor. So I want to know the voltage drop across this 5 ohms resistor. Now what do I have? I have a resistor of 5 ohms and I have a current of I1 flowing in this 5 ohms resistor. So what will be the voltage drop? From Ohm's law, we can say V equals to I into R. So if V equals to I into R, what is your current? I1. So I1 into 5 will give me the voltage drop across this resistor. So the voltage formula or from Ohm's law, V equals to I into R, we have 5 into I1. So 5 into I1. What about this? There's a 3 ohms resistor. But we have I1 also flowing here. As we see in this loop, for the first case which we do, 5 into I1, there is only I1 current interacting with this 5 ohms resistor. But in this third resistor which you see of 3 ohms, there is an I2 current which is also responding and there is an I1 current also which is flowing. So you have two currents flowing in it. You have a combination of I1 and I2. So I1 is basically flowing from this direction and I2 is flowing from this direction. So we have two directions, I1 and I2. So this is flowing in clockwise, this is also flowing clockwise, but it's flowing from this. So you have I1 flowing like this and you have your I2 flowing this way. So you have two directions. So the effective current would be I1 minus I2. So your effective current would be I1 minus I2. So plus 5I1 plus 3 I1 minus I2. Now, substituting the values, first value we have is 20 minus V2, which is 5 volts, equals to 5 I1. We'll expand this, 3 I1 minus 3 I2. So we have 5 I1 and we have 3 I1. We take it together, we get 8 I1 minus 3 I2. 20 minus 5 will give us 15. So we have 15 equals to 8 I1 minus 3 I2. So this is our first equation found. Now, in the same way, we have to go for loop 2. So now applying the similar logic in loop 2. So applying KVL in loop 2. So in loop 2, again as I told you, first find the voltage sources and equate them to the voltage drops. So how many voltage sources we have? We have V2, we have V4 and we have V3. From now I am going to directly take the magnitudes of the voltages. I am not going to be representing them as V1 and V2 because that's already understood by now. So we are going to take the magnitudes directly. So I have 5 volts voltage. Check the direction of V2. Positive, negative. So positive moves to negative. Trace the loop. So this is clockwise. So this clockwise direction is matching with your I2. So this will be positive voltage. What about V4? Positive to negative. Again, trace the loop. From positive, it is going to negative. So what is the direction? It's clockwise. Again, it's clockwise. So it is matching with I2. So this also is addition. What about V3? Positive to negative. Positive to negative. Again, it is in clockwise, which is matching the I2 direction. So all these voltages will be in addition, or they will be added up. So I have 5 plus 5 plus 5, which is equals to, I have one current I1, I have another current I2. See, if you see the loops, whichever resistors are in the loop, they are related to that current. But here, this resistor is linked with both the currents. Even this resistor is linked with both the currents. So that's the main importance of why you should circle the loop. Because when you circle the loop, you come to know whether the resistor is interacting with two currents or not. So here it is interacting with only one. Here it is interacting with only one. Here it is interacting with only one. But here it is interacting with two, because you have your loop 1 and your loop 2 touching this resistor of 3 ohms, and 2 ohms you are having loop 3 and loop 2 touching that. So you have 5 plus 5 plus 5. Again, find out the drops. So first drop will be this 3 ohms. So 3 into combination of what? I1 and I2. One more important rule. gets priority. In other words, if we consider our loop 1 here, we had 3 equals to I1 minus I2. Now I could have even said I2 minus I1, but we have to follow one standard. So when you're pertaining into this loop, this current is considered maximum. That's the reason why it has always started with I1 minus I2 and not I2 minus I1. The same logic follows for loop 2. So when you're considering loop 2, your I2 current gets first priority. So it will always be I2 minus I1. So I have I2 minus I1. What about this resistor? This resistor is only linked with I2. So I have I2. 4 I2. What about this resistor? This 2 ohms resistor? It is linked with I2 and I3. Again, you have to consider I2 first and then I3. So it will be plus 2 ohms into bracket I2 minus I2. Then again we expand this, we add all this up, it will be 15 volts equals to minus 3 I1 plus 9 I2 minus 2 I2. So this will be the final equation. So we have 15 volts equals to minus 3 I1 plus 9 I2 minus 2 I3. In the same way, we will go for loop 3. In the same way, we go for loop 3. Now, in loop 3, again, as I told you, the same logic follows. First, I will see the number of voltage sources. So, how many voltage sources? I have V3 and I have V5 inside this particular loop. Now, what is the direction? From positive to negative. So, it is moving in this direction. This is clockwise or anti-clockwise? Obviously, it will be anti-clockwise. The direction of I3 is in clockwise. So, this will be minus. What about this? Positive to negative. It is moving in the anti-clockwise, which is again reverse as that of the direction of I3. So both voltages are in negative nature. So I have minus 5 volts. What I have here? Minus 30 volts. So I have minus 5 volts and I have minus 30 volts, which is equals to now the currents. I have my I2, I have my I3 linked with this 2 ohms resistor. So I'll start with this 2 ohms. I3 gets preference because it is pertaining to loop 3. So I3 minus I2, I3 minus I2 plus 8 I3 and no other resistor. So now I again expand this term and I get it as minus 35 equals to minus 2 I2 plus 10 I2. So I have my equation 1, I have my equation 2, and I have my equation 3. So I have 3 equations, equation 1, equation 2 and equation 3. Now Maxwell's loop current method has 2 possibilities. either you could go directly for equation mode using simultaneous equation and find out, or you could use matrix. But simultaneous equation can be done directly using your calculus. So if it is dealing with 2 or 3 loops, then we can use equation mode directly and find out the answer. If it is more than 3 loops, you have to use your matrix form. Today we will only be studying about the equation mode, simultaneous equation mode. But in both the steps, in matrix and simultaneous equation mode, where you can find out the value of I1, I2, I3, you have to basically have the equations. So you have to have KVL equation 1, KVL equation 2 and KVL equation 3. It's only after this step that you can bifurcate either using simultaneous equation mode or your normal matrix. So now we got all these 3 equations, equation 1, equation 2 and equation 3. Now this is basically using KVL and finding it out. But there is another shorter cut method where you can just write these equations and come to it. Now, instead of going for these 2 steps, we can avoid these 2 steps and come to this equation, equation 1, equation 2 and equation 3 directly using a simple method. This method, as I told you, is based on the same logic. First of all, in loop 1, how many voltage sources are there? V1 and V2. V1 is 20, V2 is 5. V1, your current is moving from positive to negative, matches I1 direction. So it is positive. What about V2? 5 volts, positive to negative, anti-clockwise. So does not match I1. So it will be 20 minus 5, 50. 20 minus 5, 15. So we can directly write 50 equals to. So keep all the voltage sources on one side and voltage drops on the other side. So I just combined it directly using a simple formula, 20 minus 5, which will give me 50. Now how can I get this 8I1 minus 3I2 in a direct form? First, check your I1 current. In your I1 loop, how many resistors are there? We have 5 ohms and we have 3 ohms. So 5 plus 3 is how much? 8. So we get 8 I1. What about I2? I2 is flowing in this direction. It is flowing in clockwise. So it is moving from down to top. I1 moves from top to down. I2 moves from down to top. So that's why I took a minus sign. What ohms resistor it is? 3 ohms. It is linked with I2 as well. So minus 3 I2. So first I took the similar resistors pertaining to that current in that particular loop. And then I took the ones which are interacting with the other loop. So I combined 5 and 3 because I1 is flowing in both 5 and in 3. And I2 is only flowing in 3. That's why minus 3. So I can directly write this equation straight away, avoiding all this tedious calculation. So in exam point of view, you can directly write your equation straight away. Same way for I2. You don't have to look at that. Just see this loop. Diagnose how many voltage sources are there. We have V1, we have V4 and we have V3. Positive to negative, again clockwise. Positive to negative, again clockwise. Positive to negative, again clockwise. So all match your I2. So all this is falling in clockwise direction. So you are going to add 5 plus 5 plus 5. So what we have? 15 loops, which is equals to number of drops. Now your first drop, as I told you, if you are considering loop 2, you have to consider I2 first. So I2 is basically flowing in this resistor of 3 ohms, in 4 ohms and 2 ohms. So again I combine 3 plus 4 plus 2 because I2 is flowing in this total loop. So it is linked with 3 ohms, it is linked with 4 ohms and it is linked with 2 ohms. So 4, 5, 6, 7, 8, 9 ohms. So that's the reason why I got plus 9I2. Then what about my 3 ohms resistor? You just have to see this intersection of the loops. Which part is intersecting? So those will be the resistors which are interacting with the other loop currents. So this 3 ohms is even interacting with I1. I1 is flowing in this direction from top to bottom. But what about I2? It is flowing from bottom to top. So I1 is flowing like this, I2 is flowing like this. So that's why we have it as minus 3 I1, which is written here. So I got my minus 3 I1 as well. What about this resistor, this 2 ohms resistor? I have I3 flowing from bottom to top, which is again in opposition with I2. That's why I have I3 as 2 into I2, which is minus 2 into I3. So I am having my minus 2 into I3 because I3 is flowing from bottom to top, I2 is flowing from top to bottom. So I am having minus 2 I3. In other words, always remember, if you are pertaining to any loop, say you are doing it for KVL loop 2, combine all these resistors in that particular loop and take it as positive I2. Rest you always keep it as negative. So if there is a resistor pertaining to this, take it as negative. If there is a resistor pertaining to this loop current, take it negative. But pertaining to I2, they will all be positive. So that's why 9I2 is positive and the rest are negative. Even if you see in this loop, 8I1 is positive and the rest is negative. So we have minus 3I1. Then again, in loop 3, the shortcut method. So we'll go basically by this method to solve all our problems. Positive to negative. Again, positive to negative. So it is following a anti-clockwise direction, which is in opposition to the direction of I3. So we'll have an addition of both these voltages. So 30 plus 5 will give us 35 and it will be negative sign. Why negative sign? Because it is in opposition to this. So we have minus 30 minus 5, which will give us minus 35, which is equals to, again, in this particular loop where I3 is flowing, how many resistors are there? 8 and 2. So 8 plus 2 is how much? 10. So 10 I3. So I got my 10 I3 here. Now, what about this resistor? It is coinciding, or it is linked even with the loop current of I2. So we have minus 2 I2. So what we do is, we add the resistors 8 plus 2 because both I3 is flowing in 8 ohms and 2 ohms. So 8 plus 2 is 10. So we have plus 10 I3 and we have minus 2 I2 because even I2 is flowing in this 2 ohms resistor. But it is in flowing from top to bottom and I3 is flowing from bottom to top. That's the reason why we have a negative sign for minus 2 I2. So we can get these three equations directly. Now we can use our calci and substitute these values in our calculators using the equation mode. Either using Casio FX 991 ES, you can directly input the values of these three equations in three simultaneous equation modes and get the values of I1, I2 and I3. So the values obtained are 2.55 amps for I1, I2 is 1.82 amps and I3 is minus 3.14 amps. So we took all these three equations and substituted it in the calci. Okay, using the equation mode, and we found out the values of I1, I2 and I3. One more important thing, when you are writing the simultaneous equations, always start with I1, I2, I3. In the same way, I1 will be 0 in this case, in this loop, so we have I2 and I3. Again, we have I1 and I2. So now we got I1, I2 and I3. So I1 is 2.55, I2 is 1.82 and I3 is minus 3.14. Now the reason why this minus sign has come is because the direction we assume for I3 is basically wrong. So if the direction is wrong, we have to correct it by changing this arrow sign to clockwise, to anti-clockwise. So initially it was in clockwise, we have changed it to anti-clockwise. So we have to write here, we have done the change, draw this figure again, and now we can take this as positive. So if you get a minus sign in any of your currents obtained, that means you have to change the direction. So since I got minus here, I changed the direction. So from clockwise I changed it to anti-clockwise. That's the reason why I took out the minus sign which was there. So now I got I1 in clockwise, I got I2 in clockwise, and I got I3 in anti-clockwise. And these are my currents. Now I will input all these currents in my loops. So my first current obtained for I1 is 2.55 amps for this loop 1. So I1 equals to 2.55 amps in clockwise. I2 equals to 1.82 amps. And I3 equals to 3.14 amps. So I got 2.55, I got 1.82 and I got 3.14 amps. So I1, I2 and I3. Now I want to know what is the current flowing in my 5 ohms resistor, what is the current flowing in my 3 ohms resistor, what is the current flowing in my 4 ohms, 2 ohms, 8 ohms and so on. So if I want to know the current I1, in my I1 loop I already have it as 2.55. 5 ohms resistor is only linked with loop 1, it is not linked with loop 2. So obviously the current flowing in my 5 ohms resistor is 2.55 amps. But what about this resistor? It is linked with I1 and it is linked with I2. Now these are all the correct directions which I have inputted. So I have I1 flowing from this direction and I have I2 flowing from this direction. So what is the value of my I1? It is 2.55. What is the value of my I2? It is 1.8. Which one is higher? 2.55 is greater. So if 2.55 is greater, then my effective current direction would be from top to down, because it would be I1 minus I2. Nothing will be in negative. The only thing is that it's the direction. So which is higher? 2.55, so it will take that direction. So what is the current flowing in my 3 ohms resistor? It will be I1 minus I2. So we will now find out, we already found out all the currents flowing in these loops. Now we find out the currents flowing in each and every resistor. So I'll keep these loop currents here. So what is the current and voltage in this particular resistor. This is my modified diagram. I have changed I3. So current in 5 ohms resistor is equals to how much? I1. In my I1 input is 2.55, so it will be equal to 2.55 amps. What is the voltage in this resistor? As we know, V equals to I into R. So V equals to I into R. What will be my voltage across this? I have 5 ohms. I have my resistor value. I have my current value. So the voltage in the 5 ohms resistor will be 2.55 will be 2.55 into 5, that is 2.55 amps into 5 amps, which is equals to 12.8 volts. So in this resistor I have 2.55 ohms, I have 2.55 amps, sorry, and I have my resistor value. So it will be 2.55 into 5 will give me my voltage and current in this particular resistor. Now we will go for the second section, for the 3 ohms. Now the current flowing in the 3 ohms resistor. Now in the 3 ohms resistor we have I1 flowing here and we have I2 flowing from here. So it will be I1 minus I2. Why I1 first? Because I1 is having a higher magnitude. So it will be I1 minus I2. Again put the direction. This direction is important. So it will be I1 is 2.55 minus 1.82, which is equals to 0.74 amps. So we got the current flowing in this 3 ohms resistor. Now if I want to find out the voltage across this resistor, again I have a formula through Ohm's law which states that V equals to I into R. I have my resistance value, I have my current value. So I have my current of 0.74 and I have my ohms of 3 ohms. So voltage in the 3 ohms resistor will be current V equals to I into R. So I is 0.74 into my resistor value. So 0.74 into 3, which will give us 2.22 volts. So I found out first the current and voltage in my 5 ohms resistor. I got the value here. It becomes so simple. And I found out the current and voltage in my 3 ohms resistor, wherein I got the current and voltage as well. In the same way, we can find out the voltage and currents through each and every resistor. So now we find out. I'll just write in short form the voltage in the 4 ohms resistor. In other words, we start off with current. So current in the 4 ohms resistor will be equal to I2. I2 equals to 1.82 amps. Now again we have to find out voltage. the 4 ohms resistor will be how much? 1.82 into resistance. So current into resistance gives us the voltage drop. So 1.82 into 1.82 into 4, which gives us a value of 7.28 volts. Now again, we have to find out for this resistor. So we have the current in the 2 ohms resistor. Now current in the 2 ohms resistor, as we see the direction of I2, okay, I2 is moving in clockwise direction. So I2 is moving from top to down. But what about I3? Its direction got modified. So if direction of I3 got modified, what is the direction right now? It is in anti-clockwise. So it is moving in anti-clockwise direction. So I3 is also moving from top to down. So I have I3 and I have my I2 flowing. So it is an addition. So it will be I2 plus I3. Here what we had to find out the current in this 3 ohms resistor, I1 was flowing from top to down and I2 is flowing from down to top. So it is I1 minus I2. But here what we are having an addition. So we are having I2 current also flowing in the same direction from top to down, and we are having I3 also flowing from top to down. So it will be I1 plus I2. So both the currents are flowing in this resistor. So the effective direction will obviously be from top to down. Again I note down the direction, how I noted it down here, the effective direction. The current in the 2 ohms resistor will be a combination of 1.82 plus 3.14. So 1.82 plus 3.14. Which is equals to 4.96. Now, how we found out the current? We have to find out the voltage across this 2 ohms resistor as well. So voltage in the 2 ohms resistor would be, as I told you, V equals to I to R. I already got my I, which is 4.96, and my resistance value is already given, which is 2 ohms. So it will be 4.96 into 2, which will give me a value of 9.92 volts. So 4.96 into 2 will give me 9.92 volts. The voltage across this resistor will be 9.92 volts. Now which resistor is remaining? Your 8 ohms resistor. Now again, what is the current in 8 ohms resistor? As I told you, 8 ohms resistor is only linked with the loop 3. It is not linking with the other loops. So 8 ohms is linked with I3. So the value of I3 is what? 3.14. So the current in the 8 ohms resistor is 3.14 amps. Now voltage. As I told you, voltage equals to I into R. V equals to I into R. I is what? 3.14. Resistance value is what? 8 ohms. So 3.14 into 8. So 3.14 into 8, which gives us a value of 25.12 volts. So in this way, using Maxwell's loop current method, we can find out the voltage and current to each and every resistor in an effective way. So if you want to know a particular resistor, you don't have to do all this. If you want to know the voltage and current to a particular resistor, say 2 ohms, then you just follow this step. 2 ohms is linked with what currents? I2 and I3. So it will be I2 plus I3. That will be your current value, which is equals to 4.96. 4.96 into 2 will give us the voltage drop across this resistor. So we got a voltage of 9.9. So for whatever question is asked, whether you want to find out the voltage and current of the 4 ohms resistor, or you want to find out the voltage and current of the 3 ohms resistor, write only that step or do only that particular step. You could even do the full method, but it is time consuming if you want to find out for each and every resistor. But for whatever value is told, that value only you concentrate on. So if they tell you to concentrate on 8 ohms and they tell you to concentrate on 3 ohms, then I will only concentrate on this. I'll find out the value of current and voltage in the 3 ohms and 8 ohms. Here I have solved for each and every resistor so that you get a better understanding on how Maxwell's loop current method is done and how it can be used to find out any value of resistor in the circuit. So with this, we basically get a clear idea how to solve Maxwell's loop current method. So the first steps or the steps involved in using Maxwell's loop current method would be, firstly, whenever you get your diagram, draw your loops. I know it is time consuming, but draw your loops. So label your loop 1, draw your circle for loop 1, draw your circle for loop 2, draw your circle for loop 3. Once you get your circles, loop 1, loop 2, loop 3, assume your currents. Once you assume your current directions for I1, I2, I3, solve using KVL in each and every loop. So in KVL in loop 1, KVL in loop 2 and KVL in loop 3. Once you get your equations, that is equation 1, equation 2, equation 3, dealing with loop 1, loop 2 and loop 3 respectively, use simultaneous equation. Once you use simultaneous equation in your calculation, you will get I1, I2 and I3. If any of the values are negative, change the direction in the main diagram, which we have done. Once you get these 3 currents, write all these 3 currents here. Once you wrote all these currents, find out the current and voltage through each and every resistor, whichever resistor you are told to find out. So find out the current, say 3 ohms, it is I1 minus I2, so we got the current here. Then for voltage in this 3 ohms resistor, which will be equals to V equals to I into R. So we have the value of current flowing in this resistor, we have the resistance value, so it will be basically 0.74, the effective current here, into the resistor value, which is 3. So 0.74 into 3 will give us 2.22 volts. And this is how you can solve using Maxwell's loop current